Hey there, thank you for purchasing this course. I just wanted to jump in and let you know what to expect moving forward. So first, we're going to install Visual Studio Community 2015. That's going to be our IDE, and this is where we will be writing our code. Right after that, we're going to dive right into it and start building applications in C#. One other thing to note is that each application is going to increase in complexity. So the very first application is a good way to kind of teach you the basics and fundamentals. And if you already know the basics and fundamentals, then it's a good way to kind of fill in any gaps if they exist. So each section is comprised of the following components. First, we're going to go over the application requirements, also known as the acceptance criteria. Then we're going to write an algorithm for our application, which is basically a step-by-step process for solving a problem. And then we're going to make a flowchart that represents our algorithm. The reason why we're doing all this before even writing anything is because it is a best practice to brainstorm before writing any code. Once we're done with all this, then we're going to go over each and every single concept that you need to know in order to write the application. And then we're going to write the actual application. But then after that, we're going to write unit tests for our application in order to verify its functionality. And also, we're going to learn about unit testing in general because it is heavily used in the real world. And this is how you're not only going to learn about the academic side of things, but also what works and what is used in the real world. Lastly, I encourage you to ask any questions, and I mean any at all if you have. I'm always here and I respond to all of the questions very quickly. I'm here to help you and push you through any obstacles that you might have throughout the course. As you can see, lots of awesome stuff is coming your way, and I'm very excited to share all of this with you. Enjoy this course. So let's go ahead and download then install Visual Studio Community 2015. So you can either go to visualstudio.com/vs/community, or you can Google it and find it like that. Also, make sure that you're not alarmed by the fact that this page might not be different based on when you are actually watching this video, because they're constantly updating their website. But as long as it says Visual Studio Community 2015, you should be good to go. So it's going to be our IDE, and an IDE stands for Integrated Development Environment. It is basically an integration of separate tools that take care of separate responsibilities. Some of those tools are a compiler, a code editor, or a debugger. And an IDE is a software that integrates it all together for software developers' convenience. So in other words, it's going to help us write software more efficiently. So let's go ahead and click Download Community 2015. And then let's click on the exe. Wait for it until it opens up and initializes it for the setup. Then leave it on default option and click install. What I will do is pause the video until the installation is complete, and then we will go from there. Now that it is finished installing it, I would recommend you to go ahead and restart your computer before launching the application, but for the sake of this video, I'm going to skip that step and launch it anyways. Then I'm going to go ahead and create a test project in order to show you the basics of how it works, how everything is organized, and also just to get you used to the environment. I'm going to click Launch. It's going to open up Visual Studio welcome page, as you can see right here, and also going to do the initial setup. So here we go. Now I will create a test project. So I'll go to File, New, Project, and then I will click on Console Application, and I will name it Test Project, and click OK. Great. So let's go over the structure, the basic structure. On the right side, right here, you have your Solution Explorer. And a solution is basically an overall container. You can almost think of it like that. And a solution can have either one project, which is this is our project, or it can have many projects. But what a solution will have is it will have information about all of the projects, about their states, and about their dependencies. And we will talk about that a little bit more later. But what you want to understand is that a solution is an overall container, and then within that, you can organize your projects, and you can have one or many. And then project, as you can see, can have source files, configuration files, they can have icons, and they can have anything that is specific to that one project. And that's just how you organize your code. And going back to the program, you see here, it says main. We will be talking about methods and classes later in the course, but what you want to know is that the main method is the entry point into your application. So whenever we start the application, this is where everything will start. And the last thing I want you to know is building your application. So if we go build, and then we click on build solution, we can see right here that it says build started, and then says 1 succeeded, meaning that our application was successfully built. What this means is that the compiler, which was one of the tools that was integrated into our IDE, took the code here and turned it into something that the machine could understand, and turned it into an executable program so that we can run it independently of our IDE. So those are some of the concepts I kind of want you to think about and understand, and those are just the basics. Now, moving forward, we will be diving right into it, and we will start learning about some of the basics and then start using those basics in order to write our very first application. So very quickly, I want to show you how the updates for this course are going to be structured. As you've already learned, the course is organized within sections, and each section represents an application. Now, C# 7 along with Visual Studio 2017 have come along. So for this, the way I'm going to handle updates is by creating sections. So let's say my first application is Simple Calculator. Then my other application is Word Unscrambler. Then we have Simple Web Scraper. Then we have Sudoku Solver. Now, since the update has come through at this point, which is Visual Studio 2017 and C# 7, I'm going to go ahead and make another section, and this section is going to be specifically for us going ahead and installing Visual Studio 2017 and looking at all the features in C# 7 that are relevant to the applications that we've written. The reason why I want to keep the features relevant is because if we talk about advanced features like asynchronous programming and how that has been changed, it's not going to make sense to you because we haven't written applications on that. Once we write applications on that, then we can talk about any certain updates that come through. But for now, we're going to keep the features relevant to the applications. So within this update section, I'm going to go ahead and update some of the applications that make sense because they are relevant to the features that have been updated in C# 7. And that's how we're going to see why the features have been updated and, what's the use. And that's how I'm going to keep this course updated. Now, you might be asking, doesn't that invalidate the lectures in Visual Studio Community 2015 and the ones that have been written in C# 6? And the answer is absolutely not, because the core of C# stays the same. This language is so mature that at this point, there's only certain features being added on top of the language. More often than not, nothing gets deprecated. If anything does get deprecated, then I will just go ahead and remove the video or add another video that just makes sense in the structure. But the core of C# is the same. And actually, you will understand the updates a lot better if you look at the older versions and then move on to the updates. There is a lot more value in that. But the course will always be updated. Anything that gets deprecated will be removed or modified in the course as appropriate. And another thing about it is that as I start writing more and more applications in the course and adding them in as sections, this is how it's going to work. Let's say we right now have 4 applications, right? Then the update section is going to come through. If I write any more applications after that, then those applications are going to be using C# 7, and they're going to be in Visual Studio 2017. Then, as you've guessed, if there's another update, let's say Visual Studio 2019 comes around, right? Visual Studio Community to 2019. And let's say there are no updates to the language, then there's going to be a section specifically for installing Visual Studio Community 2019, And then the sections after that, which are applications, are going to be written in Visual Studio Community 2019. And that's how we're going to keep this course updated. You can always rely on the fact that it's going to be upgraded with the newest, latest and greatest features, and that if anything gets deprecated, that will be removed or modified. So just wanted to let you know about that so you're more familiar with the structure, and that's it. Hey guys, one last tip before we enter and start writing applications. This is about the mindset that you should have before entering the course. And it's very simple. Don't be afraid to be confused and overwhelmed. There are going to be times in this course where you're going to feel confused and you're going to feel overwhelmed. That's absolutely fine. The way I made this course is for you to be able to challenge yourself and therefore start to recognize patterns. That was the key point. I wanted a software developer, a professional software developer, to be writing software, explaining the basics obviously, but then gradually increasing the complexity. And you as a student watching that process and taking it in, but sometimes the process is not going to be very clear, and that's just fine. That means that you need to rewatch it, you need to study it, you need to ask questions. And that is where true learning happens. If it is very simple software, if I kept all my applications very simple, you just wouldn't learn. You wouldn't learn. If you entered the real world and you went to get a real job, if you are at a real job and you get a very complex project, either way, you wouldn't have gotten a value from this course. The way you get the full value from this course is by being a little bit confused, feeling a little bit overwhelmed, but asking me questions, looking around, doing your research, spending time, rewatching the videos, and learning the concepts finally. Clearing out the confusion, clearing out this overwhelming feeling. And that's how you gain confidence that you can solve complex problems. That's how you gain confidence that you know how to write complex programs, okay? You need to be okay with it. And one of the other reasons why I made this course is for students to, while they're watching another developer create programs, to take in the ways of thinking, the ways of doing, and then adopting it and using it in their own projects. And here's the magic. Over time, as you adopt these ways of doing, ways of thinking, you will see that you kind of want to deviate from it as you learn more and more and more, and as you grow in your craft. You will deviate from that ways of doing and ways of thinking. And that's just fine. That's actually how I started. And when I was an intern, I was just basically an entry developer. I would watch senior developers create software, and I would adopt their ways of thinking. And then, slowly but surely, I started to deviate from that, to find my own way. And, that is a long process. During that process, you will be confused. You will be overwhelmed. And that's why I wanted to share this mindset with you, that it's okay to be confused. It's okay to be overwhelmed. Don't be scared from it. Embrace it and use it as a tool to show you what you still need to improve on. Okay? Once again, I'm always here. Ask me any questions at any time. If you actually look at the Q&A, you will see that whenever students ask questions, you can look at the timestamp. Literally after 10 minutes or maybe a couple of hours, I answered their question. I'm always here. There might be times when I might take a day or two because I'm really busy with something, but most times I'm available and I answer questions. I'm always here for you to help you move forward and to help you learn. So it's time for us to write the first application. It is going to be a simple calculator application. The reason it's going to be simple is because it will give us a chance to not dwell on the complexity of the application, but instead focus on the basics and fundamentals and overall process we will be using to solve problems moving forward. And as we're moving forward, as mentioned, the complexity of each application in each section will increase because your understanding of each concept will be much stronger. So what is acceptance criteria? Google defines it as pre-established standards or requirements that a project or a product must meet. So these are your software requirements or feature requirements that you need to satisfy in order for it to be considered done by your employer or your client. Here is ours. As a user, I would like to be able to provide two numbers and one of the four basic operations: addition, subtraction, multiplication, and division, and then see the result of that operation based on my input of two numbers. And here's an example. We have three inputs. Two of them are number inputs, and then we have an operation. And then our output is a result of that operation based on the two inputted numbers. Now, one more thing. It is not very clear in our acceptance criteria whether we also need to add support for the words add, subtract, multiply, and divide instead of just taking care of the symbols. The reason why I made this nebulous is to make this point. In your career, there are going to be times when your acceptance criteria is not going to be very clear, and it will be your responsibility to ask questions in order to clarify any confusion. In our case, we would ask if we should support the words along with the symbols. Now let's assume that after we ask, we get the answer that we actually do need to support the words as well. So once we find that out, another good question to ask would be if we want to make the comparison case insensitive. For example, if we have the word add in all caps, should it be equivalent to add in all lowercase letters, the way we have it in the acceptance criteria, or should it be not treated the same? So once again, let's assume that after we ask that question, we get the answer that we do want to make the comparison case insensitive. And once again, don't be scared to ask questions. Even if they sound simple in your mind, don't be scared to ask these questions, because at the end, you want to make sure that you're clear about everything in your acceptance criteria. Also, it will show your client or your employer that you really care about your craft and you really care about the software that you're building. So a few other questions would be, what do we do if the first two inputs are not numerical? Another question would be, what do we do if the given operation is not recognized? These are very important questions to ask because anything that has to do with the user experience is very important. And once again, let's assume that after asking these questions, we get the answer that for each, we want to throw a specific error. So there we have it. This is our acceptance criteria. And remember, if you have any confusion in your own acceptance criteria in real life, don't forget to ask questions and be very clear in what you need to do. Now that we have clarified our acceptance criteria, it is time for us to write our algorithm. An algorithm is pretty much a step-by-step process for solving a problem. So I'm simply going to be using Microsoft Word. You can use any other word processing application. And then I'm going to use my own words in order to write a step-by-step process. Later on though, this will be translated into an actual program. One thing to note though is that for certain problems there will be many algorithms which give you the same result. Some of them being more efficient than others, but in our case the problem is so simple that even if many people had to write the algorithm, they would probably all end up looking very, very similar. So let's go ahead and write ours. First, we need our inputs, two numbers and one operation. Let's go over this. I'm saying first number equals get input from user. I'm basically saying we're somehow going to ask the user for an input and we're going to save it somewhere as their first input. Then I'm saying if that input is not numeric, then print a warning. Note that you could have written this in any way you want. You're just using your words because you want to understand what you mean by your solution, because later on you will need to translate this into an actual code. Then I say second number equals get input from user. Pretty similar thing. I say if second number not numeric, then print warning. Then at the end I say operation equals get input from user. So once again we're getting it from the user. And then remember the case insensitivity thing that we agreed with the client or our employer in the acceptance criteria. So that's what we're doing here. We're saying lowercase the operation for case insensitivity. The reason why we're lowercasing the input is so that whether it's all uppercased or whether only one letter is uppercased, at the end it's all going to be normalized and we can compare it to a constant value from our side. And you will see exactly what I mean by it when we actually write the program. Let's keep going. So then, based on the operation, we want to show the result. So we're saying if operation is plus or add, because we also had to take care of the words and not just the symbols, we're saying if operation is plus or add, then print first number plus second number. Otherwise, if operation is minus or subtract, then print first number minus second number. And the same thing will be for multiplication and division. But then, if we cannot recognize the operation, we will be throwing an error, just as agreed on our acceptance criteria. And there you go. This is our algorithm. And once again, the bottom line is that writing an algorithm gives us an opportunity to first solve this in our mind before investing any time or energy writing actual code. And as you remember, it is best practice to first brainstorm before writing any code. And by the way, if you need to access this algorithm file, I've attached it to the resources section. As you can see, I've already created the flowchart representing our algorithm from the previous video. A quick definition for a flowchart: it is basically a visual representation for an algorithm. So it's basically a visual representation of a step-by-step process that will lead you to a solution. So flowcharts are easier to understand. So if you're trying to share your solution with someone else, it is a better idea to show them your flowchart as opposed to showing them your algorithm, because it's much easier to understand and conceptualize. Once again, this gives us an opportunity to brainstorm one last time before investing any time or energy into writing actual code. In reality though, you might only have to create a flowchart and skip the algorithm creation part. You might just do it in your mind and then go ahead and create a flowchart and then go ahead and create a program. But in my course, I decided to show you all of the steps so that after you can choose which one is appropriate for your situation. Also, just a note, I'm using draw.io in order to create my flowcharts, and it's very, very simple to do that. I've also included this flowchart in the resources section so you can open it up with draw.io and change it or just play around with it if you need to. So in a flowchart, each symbol represents a specific action. Let's go over our flowchart. So as you notice, it starts with this oval shape, says start application, then all the way on the bottom it says exit application. So our flowchart should have an entry point and an exit point. However you word them doesn't matter, as long as they convey the meaning that it starts here and ends there. That's all you need. And then we have our parallelogram shape, which is our input and output. In here we're saying A, B, and operation. I could have done 3 separate inputs, but I decided to put all of them in one. And this is just our input, 2 numerical inputs and our operation. Then this is our decision shape. So this will take an input and make a decision based on that input. In this case, it says A is numeric. If it is numeric, then it'll go here. If it's not, then it'll go there. So it branches out. So then we have our rectangle, which conveys a process. In this case, we're lowercasing our operation. In this case, we're adding our inputs. In this case, we're subtracting our inputs. So, it conveys a process. Now that we know what these symbols mean, let's go over the entire flowchart. So we start our application and we get 3 inputs, A, B, and operation. Then we make decisions based on those inputs. We say, is A numeric? If it is, then we go here and we make another decision. Is B numeric? If it is, then we lowercase the operation. If any one of them is not numeric, then we will show a warning and then we'll exit the application. So if everything goes well, right, goes here, and we lowercase the operation, then we will start making decisions based on the operation. And we say, is the operation plus or add? Is it minus or subtract? And based on that, we'll either add or subtract. And so on and so forth for multiplication and division as well. If we come here and we say, it's not plus, it's not minus, it's not multiply, it's not divide, and we just don't know what it is. And at that point, we should show a warning because we've agreed upon that in our acceptance criteria. If we can't recognize the operation, we just show a warning. And then what it's going to do is once again going to exit the application. So this is our flowchart. and see how much easier this is to follow. And also, if you would want to share it with somebody else, it would be much easier to kind of show them and go over it, and also take notes on it, right? Because it gives you kind of this bigger picture perspective. One quick thing is, you might ask why I have organized my flowchart the way I did, and the answer is because it seemed appealing to me that way. It seemed intuitive to me that way. If you wanted to put these on the right side, you could have done that pretty easily and nothing would have been wrong. The only thing that matters here is the meaning behind the flowchart. So does your flowchart represent a step-by-step process that will lead you to your desired solution? If yes, then the flowchart is valid. It would be also nice that it's intuitive and appealing, which is why I organized it the way I did. But that's it for now. So as you can see, I've already created a project for myself, and the reason why I didn't do it as a part of this video is because I don't want to be doing things that you already know how to do. So let's talk about variables. This is a very fundamental concept because in our programs, we will always want to store data, then be able to retrieve that data and do something with it. This is what variables allow us to do. However, since C# is a strictly or strongly typed language, that means that our variables should have types. So when we are creating or declaring our variables, we should specify what type of data we're trying to store in them. For example, we might want to store numerical data in some variables, and then we might want to store textual data in some other variables. Then there are different types of numerical data, such as integers or decimal numbers. We also need variables to be able to save more complex structures as well, but we'll talk about those a little later. So let's create some variables. I will go ahead and say string some text equals here is some text. Now let's go over the format. First, we have our type. So this is the type for the variable, and it says string. String allows us to store textual data. And string is a reserved keyword, meaning that it's part of the language. If it's misspelled, it won't be recognized, and your program just won't run. It won't be built. So let's say if we just remove one letter, see, it's underlined red, meaning that it is not being recognized. And another good thing about the IDE is that you get these quick feedbacks, which allows you to fix any errors right there and then. So we'll just bring it back and say string. Now it's recognized. And it has to be exactly the way it's written here. So then after that, it comes the variable name. And this can be anything you want, but you want to keep it descriptive so that you understand what it's storing inside. Then we have our assignment operator. We'll go over operators in our next video, but all you need to know is that it takes the value on the right side and assigns it to the variable on the left. And then we have the actual data that goes inside of the variable. So there you go. Now let's declare another variable. I will say int number equals 10. Int is another type which allows us to store whole numbers. For example, if I try to say 10.9, which is a floating point number, it won't work because the value is not compatible with its type. If I want to store a floating point number, then I have to use the appropriate type. One of the appropriate types will be double, and I can say another number equals 10.9. See, in this case, I have the value compatible with its type, and that's why it works. Let's go ahead and write another one. I will say bool is ordered equals true. And bool is a very interesting type because it allows only two types of values, true or false. And another thing is that whenever you're naming your Boolean variables, you want to keep the name so that it's either asking a question or verifying an idea, because that way it's a lot more intuitive. Now the next one is very interesting. We're going to learn how to get input from a user, and we're going to do that with a pre-written class and a pre-written method that is accessible to us. It's called console readline. So the console is the class and readline is the method. And we'll go over classes and methods later down the course, but for now what I want you to know is that this is available to us and many other methods and classes. They're pre-written and we have access to them right out the box. So this will allow us to get the input from a user, but now let's store it in a variable. One thing to note is that whenever we're getting an input from a user, it always comes back as textual data. So What is one way we can store textual data in a variable? Exactly, string type. So what we can do is we can say string input equals console read line, meaning that the console read line will get the input from a user, then it will save it inside of the variable. And that's great. Let me show you another one. Var anything equals 10. Interesting, right? It just worked. What if I do this? Still works. What if I do this? It still works. So var is an implicit type, meaning that anytime you assign a value to it, it automatically figures out the type, meaning that you don't explicitly have to specify the type. That's why it's called an implicit type. And it's very good to know as we're writing more applications. It's actually very, very useful. So now let's go ahead and print the values within our variables. We're going to do that using another pre-written method that we have access to called Readline. And it's also in the same class called console. So we're going to say console, Readline, and then we're going to say some text. Now let me do the same thing for number. Another number is ordered, input, and anything. Let me copy the names real quick. There you go. And then I will breakpoint this. So a breakpoint allows us to break the execution flow of the program. Basically what happens is that whenever we run our program, it starts executing statements line by line. And when we breakpoint it, it stops at that current point and shows us the current state of the application. So I'm breakpointing at the very beginning, and then I will manually step through each and every statement. Now let's go ahead and click start. And start, what it will do is it will build the application first, and we've already went over what building does. So it will build the application, then it will run it. So let's go ahead and do that. And see, since I breakpointed it, it stopped right away. And then I will click step over, which will step over every statement manually. So we'll go here and see here, it shows us the current state. So it says some text equals here is some text. So we can see the variable and their values. Now let's go all the way to input. See, it stopped. That's because it's waiting for an input from the user. So I will say, this is me. And see, it went to the next line because I got the input from the user. Then I will print all of the values. And let's open it up. See, it says, here is some text. That's here, 10, which is the number, 10.9, which is another number, true, which is ordered, this is me, which was the input, and then 10.9, which was anything. So that's great. One more thing to note is that there's actually a lot more built-in types that I didn't go over, but the reason is because, number one, it will be extremely boring for you to watch me go over each and every type separately. I'm pretty sure you already got the point by the third or the fourth one. And the second thing is, and I strongly believe it's much more important to understand the general concept behind all this than to memorize specific things. So I'm pretty sure you already understood the concept, and since you understood the concept, you can then apply this same thing in your specific situation. So if you need to learn about the rest of the types, you can simply go to Google and then type in MSDN C# built-in types. I already have that. And then you can click on msdnmicrosoft.com and it'll give you all the built-in types. Now it's very nice because we already know some of them, double, int, right? And you can click on them. I want to show you something. See here, it says range. So an integer, this is the range of values that it can hold. So see, if we put anything that's above it, it will break. Let's go check out double real quick. See, the range is much larger, so it's giving us a lot more precision. So that's actually very good to know if you're writing an application that is very scientific and you need to know how large your value should be, so how much memory you need to allocate for it. But once again, since you know the concept of a variable, now you can apply it in your specific situation. And once again, variables are just a way for us to store values and then retrieve them and do something with them afterwards. And in C#, since it's a strongly or strictly typed language, we need to specify types for the data that we're trying to store. Let's quickly talk about expressions and operators. An expression is a series of operators and operands. Now, operators are symbols that represents an operation, and operands are basically inputs for the operator. Let me show you a quick example. I will say int result equals 10 plus 10. See this? We already know how to declare a variable. We say first the type of the variable, then the name of the variable, then we have our assignment operator. I will go over that in a little bit as well. And then we have our value. But notice that in this case, we don't have a single value. Instead, we have an expression that gets evaluated down to a value. Now let's look at the formatting of our expression. First, we have our operator, then we have the operands. So in this case, it's an additive operator, and then we have operands for it. And this gets evaluated down to a value, which then gets stored in our result variable that is of type int. One question might be, what is evaluation? And evaluation is basically applying the operator to the operands in a proper sequence to get that single value. I guess the next question would be, what is this proper sequence? And there's a very good question, but I will answer it in the next couple of videos. But for now, just know that that proper sequence is called the order of evaluations. And the order of evaluation is what we use in order to evaluate the expression and then get that result that we want, which we are going to store inside of our variable. Now, another thing to know is that we can have much more complex expressions. And the way we do it is by attaching an operator to it. So let's go ahead and say minus 100. Basically what we did is we attached another operator, and this operator needs two operands. Once again, it has this and it has that. We can make it even more complex. We can say plus 1000, right? This also has its operands on the left side and on the right side. Now we can also have a variable inside of our expression. So we can say int number equals 90, and then we can say minus number. So as you can see, we can also have variables that already have a value, and we can have those variables within our expressions. Now, this is not really the most interesting case because it would have been interesting if we actually took an input from a user and then used that value inside of our expressions. And we can totally do that. I will also go over that in the next couple of videos. But for now, know that we can just use variables in our expressions. Now, one other thing to know is that there are a lot more operators out there. And the reason, once again, I didn't show you all in this video is because, once again, it will be very boring for you to watch that. But second, it's much more important to understand the concept behind it. And so to know the rest of the operators, you can actually go to Google and type in C# operators and click on the one for the MSDN link. And then you can see here C# operators. As you can see, you have primary operators, you can have unary operators, multiplicative operators, additive operators. One thing you'll notice is that some operators require one operand, others require more, but it's exactly the same idea. The operator gets applied to the operand, and then you get a single value back. So in summary, we've learned about variables, which allow us to store data, and then we've learned about expressions, which allow us to perform operations on data and then get a single value back, which we can then store inside of our variable. So as you can see, I still have the expression from the previous video. And the reason why I still have it is because I want to go over an example where we're taking an input from a user and then converting it into a number and using it in our expression. Remember that whenever we take an input from a user, it always comes in as textual data. So we need to convert it into numerical data. And you know that in C# we have different types of numerical data. And one of them is int, one of them is double, and there's many more. But in this case, we're dealing with an int. So what we want to do is we want to take an input from a user and then convert it into a type of int, then use it in our expression. So let's go ahead and do that. You already know how to take an input from a user, so I will say string input. See, I misspelled it, so I will say string input equals console readline, and then this is our input. So now Let's learn about how expressions get evaluated down to a single result. So strings, let's talk about them. Strings, as you already know, allow us to store textual data. First thing I want to talk about is string comparison. So let's actually go ahead and create a couple of strings. I will say some text. Here is some text. And then I will say string some other text. Here is some other text. So now we have the strings. Let's try to compare them. Remember how I told you that types have pre-written methods that we can access? We've tried try parse on int, and you also know that other numerical types have the same type of methods on them. And string is a type that also gives us access to pre-written methods. One of them is equals. So I can say some text, and then I can say equals, and then within that I can say some other text. See that? So it's going to compare the strings together. And equals is a method that returns a type of bool. And once again, you know that it's either going to be true if they are equal or false if they're not. But one thing to note here is there are three types of comparisons that we can do. If we do put a comma here, you can see that we can pass in other things in here. And it's called string comparison options. So there are three options for us. One is ordinal, the other one is invariant culture, the other one is current culture. I won't be going over them in detail, but what you want to understand is that ordinal pretty much does character by character comparison. When it comes to current culture and invariant culture, those two take into consideration specific language rules. So current culture takes into consideration the user's current region, so the regional language rules. And when it's invariant culture, it's taken into consideration some neutral cultural rules, aka what's mostly being accepted and done in the United States. So as long as you're not doing any language specific, culture specific text comparisons, then you can go with ordinal, because ordinal is a lot faster. It has faster performance. Some people say that whenever you're comparing strings, you want to always be doing invariant culture so that if it's need to be taking into consideration certain language rules, then it will. But I say that if you know exactly what your application is going to be doing, then use what you need to use. So if you need to use ordinal and you know you're not going to take into consideration any language rules, then just use ordinal because it's a lot faster. Otherwise, go with either one, either culture invariant or current culture. In this case, we'll be using ordinal. So I'll say ordinal, and then let's assign this to a variable because this is going to return a value back. This essentially is an expression, and it's going to evaluate down to a Boolean value. So let's say bool is equal, and now let's actually run this real quick. Start, and let's hover over it. See, it says false. That's because they're not equal. Now let's try to make them equal. So I will change the contents of some other text, and I will make it so that it says here is some, and I will take the other, and let's see what this does. I will stop it, run it again, and you can see that it's true now. Now one more thing. What if I change the casing here and I make this a capital letter? Let's try it again. And restart. So you see, now it's false. Why? Because it's case sensitive currently. But what we can do is we can do the ordinal comparison, but with case insensitivity. So we can say ignore case. Ordinal, ignore case. In this case, it should say true. See that? It's true because the contents are the same and it doesn't care about the casing anymore. Let's talk about string concatenation. Concatenation is basically the process of putting strings together. Let me go ahead and do that. I will say string added text equals some text plus, I'll put a space here, and then I will say some other text. And then actually let's add some more stuff to it. I will say here is some more text. Okay? So this is an expression that will evaluate down to a string value and then be stored in this variable. However, adding strings together like this is not the best way, and it gets very messy very quickly. So there are other ways to do it. One of them is using a string builder, which I will be going over a little later. And the next way is using string formatting, which I will be showing you now. So let's go ahead and do that. I will say string, formatted string, and I will say string format, which is a pre-written method that we have access to that's on the type string. Then I will say 0, 1, and here is some text. Then I will say some text and some other text. Let's see. So these two will have the same exact value. We're actually going to print it out. I'm going to say Readline for added text, and also I'm going to print out formatted text. Let's actually see the values. See here? Here is some text, here is some text, here is some more text. And the same for formatted text. So now that you saw that they're exactly the same at the end, let's actually go over how formatting works. So first, you specify to the method your template, how you want the end result to look like. See, we don't even have to specify the spaces, like we don't have to add spaces separately. We can actually just have a space in the template and it'll take care of it. And then we inject the values that we want into the template. So these are known as the format items. And the format items, we specify them in sequence. So first one is 0, second one is 1, and here is the actual format items. So we're saying first we want to see some text, then we have a space in the template, then we want to see some other text, then we have a space again, then we want to see the rest of the text, right? We could also, if we wanted to, we could have taken this out, and the next would be 2, obviously, right? 0, 1, 2. And then we could have had it here in double quotes. And there you go. This would have been the same exact thing. But since we know this is a constant in our case, and it's not in a variable, we're just going to put it in the template. It's up to you. But this is how you can build and structure text in a much cleaner way. A couple of more things to know is that strings have lengths and strings have indexes. So we can access their specific characters within the string. Let me go ahead and show you. So I can say console Readline, and I will get some text, and then from that I will say length, which is a property that we have access to. Once again, properties are another thing that we'll be talking about later. But just for now, know that strings have a length property that just gives out their length. In this case, we will see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we should see 17 for the length. Now, let's actually go ahead and access a specific character in this string. So I will say, by the way, it starts from 0, not from 1. So the index starts from 0. So you count 0, 1, 2, 3, 4, 5, 6, 7, 8. Let's put 8 here. So we expect to see 17 for the length, and we expect to see capital letter S for the specified character. Let's go ahead and see that. And as predicted, 17 and capital letter S. Another important concept to know about is substringing. So this is going to allow us to get a part of the string. Let me go ahead and show you. I will say console Readline again, take this one out. And then what we're going to do is we're going to get the word sum. So we'll go ahead and say sum text dot substring, which is another method that's on any type string that we have access to. And then I'm going to say 8. Why 8? Because we already know that is going to be 8 for this index. We can count again. 0, 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 for here. And then what you want to do is you want to pass in the length. So how many characters do you want to count forward? So start from 8 and count forward. So you say 1, 2, 3, 4. And there you go. Now, one thing you want to know is that the starting point is going to be included. So whatever you start from, it's going to be included in here. So let's actually go ahead and print this. And here you see sum. A couple of other methods that are pre-written for us on the string type are to lower and to upper. These will allow us to uppercase or lowercase the entire string. So let me go ahead and show you that. I will print some text, and I will print it first by lowercasing the whole thing, and then I will print it again by uppercasing the whole thing. I'll say to upper, and these are both pre-written methods that we can use right out of the box. And let me show you what they look like. See? Lowercased, all uppercased. That's great. Now, one other thing I would like to show you is we can declare variables and say another string, right, or another text, and just assign it to double quotes, which will create an empty string. However, there is a lot cleaner way to do this. Instead of doing this, you can just say string.empty, and that will create an empty string. So whenever you want to create empty strings, use this instead of just having double quotes. It's not as clean. And another thing is you don't want to be using string literals in your source code. The only time you want to be using string literals, and string literals are pretty much what you see right here, you have a value of string laying in your source code. The only time Let's learn about conditional statements. So conditional statements allow In this video, we'll be talking about objects and classes, and it's very exciting because it is the first step towards learning In this video, we'll be talking about methods. The reason why I went over objects and classes first before even talking about methods is because we can only talk about methods in the context of objects and classes. I'll tell you why. Because everything in object-oriented programming languages, such as C# is organized in classes. So all of our code is organized within the classes, either all in one class if our application is small enough, or it's chunked out throughout multiple classes, and then the classes interact with each other. But in any case, classes are the main containers. They are the blueprints where we have our code, and then those blueprints interact with each other. And that is how our application is organized. Now, what a method is, it is basically a group of statements that perform a process. That's all it is. They perform a process, and sometimes they return back a result, and sometimes they don't. For example, when we create our project newly, then we are given the default class, which is program, and then we have our method, which you already know is the entry point into the application, which is called main. And we can pretty much have all of our program within one class. It's not recommended, but you can. Or if you want to chunk it out within other classes, then you can have other classes which interact with program, and program interacts with them. But that's what I mean when I say that our code is organized within classes. So I'm actually going to go inside of the person class, which you can do by clicking on the person and then pressing F12, which is a pretty nifty shortcut once again. So I'm going to go ahead and create two methods. I'm going to say public int get age, and then return age. Then I'm going to say public void set age int new age, and then age equals new age. There you go. Now, before I go over methods, I want to talk about what the deal is with this underscore age, because you might say, where does that come from? And currently it does not exist, so I'm actually going to create it and then talk about it for a little bit. So private int age equals 25. Okay, so what is this? Because you thought we're only going to be talking about methods, and you're correct. But in this case, I'm introducing a new concept which we will be going over later down the line. This is called a field. So we can have fields, properties, and methods. Currently, this video is focused on methods, but as I said, I lightly touch upon fields as well. So a field, there's really not much to it. It is basically a data within our class. So you see, we have an access specifier, so we're saying it's private within the class. And we can have different access specifiers. Once again, we can have public, which would mean that any other class could use this or would have access to it from outside of this class. But in this case, we're saying private, so it's only accessible within the class. And then we have the type for that field, and it is an integer. Then we have the actual name, and then we say equals, which is the assignment operator, and we assign a value to it. That's all. So we have this field, but now let's go over the methods. So let's go over the formatting of a method. First, once again, you have your access specifier. Is it public? Is it private? In this case, it's public, which means that any other class might access this method. And it's not just accessible within this class. So that's what this access specifier means. You can have access specifiers for your classes, for your fields, for your properties, and for your methods as well. Then you have your return type. Return type just says that this method will be returning a type integer. So it's going to process, it's going to do some stuff within the method, and then at the end, the result will be of type integer. Then we have the actual method name, which you can have it as anything, but just try to keep it as descriptive as possible. And then I can have parameters or no parameters at all. In this case, we don't have any parameters. In the case of the other one, we do have parameters. Only one parameter, but if you wanted to have other parameters, then you would just say comma and another parameter. So param2 or anything else you want, or any other type you want. This could have been a string as well, or anything else that you need to pass into the method for its processing. In this case, we only have one parameter. So it's int new age. Now, this first line is called the method's signature. So its access specifier, its type, return type, its name, and the parameters are called its signature. Then we have the body of the method. The body goes within the curly braces, and in this case, it's not really that complex of a method. It's just returning the age. That's what the return stands for. By the way, return is a branching statement. Remember how I was talking about flow of control statements and how there are three of them, conditional, looping, and branching? Well, return is a branching statement. Why? Because it changes the flow of the program. The moment you hit this, it will actually exit out the class and go to where it was called from. If we call it from the program, it will actually come right back to this class and continue execution from there. That's why it's a flow of control statement. And that's very good to know. Now in this case, I think it's pretty self-explanatory. We are calling getAge, returning the field that we have set here that's only accessible within the class. Then the other method takes a parameter from the outside and then uses the value of that to assign it to the field. So this value will change when we call setAge and pass in a new number, which is going to be the new age. Now let's go ahead and actually use these methods. So I will go to program, and then I will say person 1 dot setAge. Actually, let's do getAge first, and then I will say person 1 setAge, and I will say 29, and then I will say getAge again. Now we actually want to print these, so I will use console Readline and print this one, and then I will use that again and print the other one, so we can actually see the values changing. And let me breakpoint here. Let me start the program. So you see, if I step over and step over again, you'll see that it says 25, right? But if I set age, and I will actually step into it so we can see how it steps into the method. See here? The age is 29 now. If we go here, this is 29 and this is 25, but it will be changed now. See, if we have over it, age is 29 now. I go here, and go here, and I print it, you'll see 29. So there you go. There you have it. But one word of advice about methods. So methods, as you already know, they're a group of statements that perform a process and give a value back. And sometimes they don't give a value back, which is why the return type is void. In this case, we're not returning anything. So the return type is void. And that's absolutely normal because methods don't always have to return things. Sometimes they don't want to return anything. In this case, it's totally acceptable. And that's why we just say void. So void just says this method won't be returning anything. But the other thing is that you want to keep the name of your methods very descriptive, and the reason why we have methods is so that we can have code reusability. Now, what is code reusability? That means that if we have a method that does something already, then we won't have to write that code again. All we would have to do is use that method from different places, and it would do the same exact thing that we want, but we'll only have that code in one place, which makes our maintenance a lot easier, because if we want to change that method, we only change it in one place, and also it keeps things very organized. And for now, that's it. So let's talk about static versus non-static methods. In order to do that, I will have to go inside of the person class, and then let's look at the getAge and setAge methods. So have you noticed that we have to create an object, and then from that object we then use the method? What if I tried to say person.getAge? What would happen? See? It underlines it. So it actually can't recognize this method. Reason being is because the method is non-static. So non-static methods on classes can only be accessible if an object has been created for that class, and then from that object we have access to those methods. But if we have a static method, then we can have access to that method right from the class. Let's actually go ahead and create a static method. I will say static public void greet, and then I will say console Readline and hello. So then let's go back to the program and say person greet. See that? This works. Get age was underlined red because it was non-static, but this one works just fine. And it'll work even if I breakpoint here, just so that the console doesn't close. And let's actually check it out. See, 2529 from the previous example, and then hello. So we're able to access it on the class. Now let's go ahead and take a look at the format. So I will go inside of the person again, and let's look at the static method. So you see that the only difference here is that I have the static keyword, which is a reserved keyword again. And if you take it out, then it automatically becomes a non-static. So if I take this out actually, and then go back to the program, you'll see that it's being underlined red because it can't be recognized. And that's because it's non-static, as you already know. But I will make it static once again. And then actually a very interesting thing is, remember the console class, which we have been using for a long time now. We've been writing things to the console, and we've been also using Readline to get input from a user. Those methods that are on console class, they are actually static. The way we can actually look at the method signature is by right-clicking on the method and then going to go to definition. And you can see here within the console class, we have the Readline, which is public static void. This is its signature, the method signature. And it is a static method, meaning that it does not need for the class to create an object. So we can actually have access to this method right from the class. Let's go back. Now, one quick thing is you might notice that in my static method, I don't really need anything from the class. So I don't actually use the age, and I don't pretty much use anything. It's very self-sufficient, and it's just printing something out. Now, that's actually how you want your static methods to be. Though, static methods can still use things from within the class. So if I actually made this field into a static field by just saying static in front of it, then I can use age in here, and I can actually just print the age, and this would work. But if the field was non-static, then this wouldn't work. So actually, let me just put back hello. The thing with statics is that even if you can have static fields within your class and then use them in your static method, you still don't want to do that. The best practice with having static methods within your class is by keeping them self-sufficient, meaning that they have everything that they need in order to perform the process. In this case, it's just printing something out to the console. In your case, it might be something else. But static methods, you want to make sure that they don't have any dependencies on the class. They're very separate. Otherwise, if they need something from the class, then you want to make them non-static. And that's the best practice with static versus non-static.